Imagine for a second that everything you thought you knew about the sort of family tree of the cosmos, well, what if it was missing a whole branch? For ages, we've basically sorted galaxies into two main groups, you know?
Right, the standard picture.
The youthful, vibrant blue ones just buzzing with new stars.
Uh-huh, the star factories.
And then the stately, often reddish ones where, you know, the star nurseries have pretty much gone quiet.
The retired one, so to speak.
Exactly. But what if that neat division, what if it's actually hiding something much more fascinating, a more complex reality?
Okay, I'm intrigued.
Well, if you're always on the hunt for knowledge that really shifts your perspective, you're about to dive into a pretty revolutionary idea, something that's making astrophysicists, well, rethink some basics.
That's right. We're taking a deep dive today into a new way of classifying galaxies. This is spearheaded by the work of astrophysicist Charles Steinhardt.
Okay.
And forget the simple blue versus red. He's proposing this crucial third category. Red star-forming galaxies.
Red star forming.
Yes. And look, this isn't just some minor footnote. The implications drawn from his research, there's a paper in the Astrophysical Journal that could fundamentally alter how we see the universe evolving.
Wow.
So our goal today is really to unpack this new type, explore why it's so significant, and, show how it might rewrite some pretty established chapters of cosmic history, all tailored to give those aha moments.
Okay, right. So let's revisit that classic picture. You know those amazing Hubble photos?
Oh yeah, breathtaking.
You often see these galaxies like dazzling blues and deep reds hanging out almost side by side sometimes.
It really reinforces that two-type idea visually.
It does. Blue galaxies, we're told, are young. They're actively making stars. Red galaxies are older, star-forming days mostly done. It's clean. Easy to grasp.
Indeed. And for a long time, this blue-red dichotomy, it's been a cornerstone, really central to how we thought galaxies change over cosmic time.
Makes sense.
The blue light, it's a clear signal, right? Hot, young, massive stars. Cosmic rock stars, basically. Burn bright, live fast, die young.
Okay.
And conversely, the red hue tells us we're seeing older, cooler stars. The long-lived embers that are left once that burst of youth fades. It's been a really useful visual shorthand for astronomers.
But now Charles Steinhardt comes along and, throws the seemingly straightforward picture into, fascinating disarray. Red star-forming galaxies. It sounds almost contradictory.
It does, doesn't it?
Yeah.
Red and forming stars.
Yeah. How can a galaxy look red if it's still, in the business of creating new suns?
Well, okay, here's the really intriguing part. The reason they look red is not because star formation has stopped. Instead, these red star-forming galaxies are actively giving birth to stars. But, and this is crucial, they're primarily producing low-mass stars.
Low-mass stars, okay.
Now, unlike those massive blue stars that burn fiercely and quickly, these smaller stars live much, much longer. And their energy output, it's concentrated in the redder wavelengths of light.
I see.
So a typical blue galaxy turns red because it gets old. A red star-forming galaxy is red because of the kind of stars it's making right now.
That's a really important distinction, then. It's less about the galaxy's age, maybe, and more about its stellar recipe, the kinds of stars it's cooking up at the moment.
Exactly. It's the stellar population mix. And Steinhardt puts it very succinctly, he says, red star-forming galaxies primarily produce low-mass stars, making them appear red despite ongoing star birth.
It's subtle, but potentially game-changing.
Precisely. And this isn't just, adding another color to the galactic crayon box.
Yeah.
If we connect this to the bigger picture, how we understand the universe well, these red star-forming galaxies start to offer some elegant explanations for nagging inconsistencies.
Like what? What inconsistencies?
Well, for instance, we've puzzled over the observed ratios of black hole mass compared to the total stellar mass in galaxies. Doesn't always quite line up with models.
Okay.
Red star-forming galaxies, by adding maybe a significant previously unaccounted for population of stars, could help bridge that gap. And similarly, there's something called the initial mass function, basically, the distribution of star masses when they're born. It seems to differ between blue and red galaxies.
Right.
And just saying galaxies get old or merge doesn't fully explain why that difference exists. Steinhardt's work suggests these red star formers might hold a key.
So these could be the missing ingredient. The key page is missing from our cosmic cookbook, as Steinhardt puts it.
That's a great way to phrase it.
And the potential ripple effects sound significant. He even proposes, and this is a big one, Most of the stars we see today might have formed under different conditions than we previously believed.
Yeah, that's a statement that really makes you pause. It questions our fundamental grasp of stellar history.
So what does this do to the narrative, the story we tell about galactic history?
Well, it raises a really important question. If a substantial fraction of galaxies has been sort of quietly forming stars while looking red, then their contribution to the universe's total star count might be far greater than we thought.
Right. We might have missed a huge chunk of star formation.
Exactly. They could reshape our understanding of the typical life cycle of a galaxy.
Yeah.
And it definitely impacts how we've been measuring total star formation across cosmic time.
So if we've mostly been looking at the bright blue, obvious star factories,
we might have been significantly undercounting, underestimating the universe's total stellar output.
and Steinhardt emphasizes this point. He says, the existence of these galaxies could mean that the universe has formed significantly more stars than previously estimated.
Which is huge.
And he adds, it supports the idea that the life cycle of galaxies is more complex than a simple progression from blue to red and dead.
It paints a much richer, more nuanced picture. Not just a one-way street from blue youth to red old age.
Okay, so more complex life cycles. Does this affect how we see other types of galaxies?
It does, actually. It throws an interesting new light on galaxies we call post-starburst.
Post-starburst. Okay, what's the standard idea there?
The conventional understanding is these are galaxies that had a sudden, really intense burst of star formation.
Like after a merger, maybe?
Often attributed to mergers, yes.
Yeah.
When galaxies collide, you get this burst. But then the star formation shuts down relatively quickly, gets quenched.
Right, the fuel runs out or gets blown away. A dramatic boom and bust cycle.
That's the picture. But Steinhardt offers a compelling alternative view for some of these.
Okay.
He suggests that at least some galaxies we've labeled post-starburst might not have had a sudden burst at all.
Really? So what are they then?
They could actually be red star-forming galaxies. Galaxies that were slowly and steadily producing those low-mass, redder stars all along.
Ah, so what looks like the end of a burst.
Might just be the ongoing low-level simmer of star formation that was never particularly intense in the first place. We mistook the quiet baseline for the aftermath of a frenzy.
That's a fascinating twist. So we thought dramatic on-off switch, but maybe it was just consistent low-level red star production all along?
For some of them, potentially, yes.
And we just misread the signs based on the color and assuming the old model.
Exactly. It really underscores the importance of, well, not just taking a single snapshot in time. We need to look deeper than just color to understand the history.
Wow, okay.
It implies our definition of post-starburst might need a serious rethink. Some of these enigmatic objects might just belong to this newly recognized class.
It really highlights how the universe can be more subtle, more nuanced than our initial categories sometimes allow for.
Definitely. Nature isn't always neat boxes.
And it's clear this isn't just theory. People are actively working on this. It's exciting to hear about Steinhardt and his students at the University of Missouri.
Absolutely. This isn't just an idea floated out there. They're doing the hard work, looking for observational evidence.
Trying to ground truth it.
Exactly. And what's really encouraging is the student involvement. Junior to Harper, undergraduates, they're digging into data right now.
Looking for what specifically?
Looking for evidence that some galaxies we currently call post-starburst are, in fact, these red star-forming galaxies in disguise. That's crucial detective work.
That kind of hands-on investigation is vital, isn't it, for testing these big new ideas?
Couldn't agree more.
And it's not just looking far away, right? There's work happening closer to home, too.
Yes, that's right. Sophomores Carter Meyerhoff and Zach Borowiak are using data from the Gaia satellite.
Ah, the ESA mission mapping our Milky Way.
Precisely. Mapping over 2 billion stars in our own galaxy with incredible precision.
How does studying our galaxy help with understanding these distant red ones?
Well, by understanding the details of stars, here their properties, how they're distributed, we gain crucial insights into the fundamental processes of star formation itself.
I see, like a local laboratory.
Exactly, a local baseline. Those insights can then be applied when we interpret the much harder to get data from distant galaxies, including these potential red star formers. It's all connected.
The story of our galaxy helps tell the story of the universe.
Beautifully put, yes.
Yeah. Okay, so for you, the listener, always trying to connect the dots, get the big picture without drowning in details. The key takeaway seems to be this. The universe is probably even more dynamic, its history more intricate than we thought.
That's the heart of it.
This new idea, these red star-forming galaxies, they really challenge some bedrock assumptions about how galaxies live, evolve, and fill the cosmos with stars.
And it's a powerful reminder, isn't it? Science is always evolving. Our understanding deepens.
Yeah.
What's truly fascinating is how something seemingly simple, like the color of a galaxy, can actually mask this whole complex, ongoing process of starbirth.
It makes you value questioning assumptions, looking deeper.
Definitely.
It really does make you wonder, then, if our understanding of something as basic as galaxy types was incomplete because of this overlooked category. Could our understanding of other cosmic stuff also be missing pieces, because of similar assumptions we haven't questioned yet?
That's the provocative thought, isn't it?
Yeah. Are there other red star-forming equivalents hiding in plain sight in other areas of astronomy, other neat categories that are maybe too simple?
It's entirely possible. It's what keeps science exciting. There's always more to discover, more layers to peel back.
A truly vast cosmic landscape still out there to ponder and explore leaves you thinking.